internal resistance. We are going to study internal resistance of cell, but you see it's unavoidable. And moreover, it's not going to be the property of the cell. Rather, it is a drawback, demerit of the cell. It is highly undesirable, but we can't adjust without it. You see, we have to ultimately accommodate internal resistance of the cell, which is very small for secondary cells and larger value for primary cells. Internal resistance is always represented by the letter small r. It is the obstruction offered by electrolyte and electrodes in the flow of the current. Obviously, it is all the story inside the cell, so logically it should be represented inside the cell only, as I have shown here. This is a bit typical to be followed throughout, so we use this method. Theoretically, we also prefer this, but not often. This is the most common method that we adopt in our electrical circuit for daily calculations. You see, when internal resistance is to be added, you have to take care whether it is series or in parallel. Like this, it is in series, we have followed the series method. Here, the two resistances are not looking in parallel, you see. But once you keep and you are very clear, having crystal clear idea in your mind that it is inside, it is just for the sake of representation outside, then you will come to realize that the two resistances here are in parallel because they are here within this cell. So once they are in parallel, you find the resultant. In case of circuits, two terms are very common, closed and open. It's not like lock getting closed or open. It's a technical term. When the current is flowing in the circuit, it will be deemed as closed circuit. And when there is no current, it might be with the help of a key, or even you could simply loosen a wire and take it away from the circuit. Then in both the cases, you would say that this is open circuit. Open circuit simply means there is no current. Remember, the circuit might be closed and you are not having the current. In that case also, you will say that this is open circuit. You see, closed circuit, we are considering the example in which only the external resistance has been considered. Internal resistance is already with the cell. Total resistance here would be R plus R and the current. You are having a cell means you have to adjust with the EMF and internal resistance of the cell. You don't have any control over that. So in order to get the variation in the value of current, obviously you'll have to control only external resistance. In order to decrease the current, you have to increase this. In order to increase the current, vice versa. I maximum is possible only when the external resistance becomes 0. When you take R equal to 0, you are going to get the value of maximum current, that is E upon internal resistance. Voltage output here across this load resistance is going to be I into R, and if you put the value of I, you are going to get E upon R plus R. This could be, see, little modification it requires. This could be rewritten as 1 plus R upon R. You want the maximum value of potential difference. For that, you need this denominator to have you want this maximum, this will have to be minimum. For this second term, R upon R should be 0. Minimum possibility is only 0 here for resistances, because LC and R can never be negative. This could be 0 only if you take capital R as infinity. Then in that case, this is going to be 0, and maximum value of E is going to be capital E itself. So two things are 0, I maximum, R infinity, V maximum. Now what comes is the power. For getting power, power output, this is I square R. You put the value of I here, this becomes the formula. And if we try to find out the condition for maximum power, we'll conclude that both the resistances should be equal for getting the maximum power. you put this value R replaced by small r, then you are going to get the maximum power E square upon 4R. And now in the last, if you want to find the internal resistance, you see E equal to I, R plus R, this relation, V equal to I, capital R. E upon V will be 1 plus R upon R. And that way you get this relation. This is most commonly used for finding internal resistance. We also use this relation while finding the internal resistance with the help of a potentiometer.